Welcome back, students. This is the Q&A session 1 of JEE Physics Part 1. Now this is the this is the playlist which I have created today, and in this playlist I will be taking up the questions which were asked in the JEE examinations, and the questions which I will be taking up, it will be from the syllabus, from the class 11 syllabus of CBSE and the IIT board. So, so the first chapter which I will be taking for this means the first chapter which I have taken for this Q&A session 1 is the chapter of units and measurement, because that is the first chapter pertaining to the this class 11 CBSE and the IC syllabus. So from this chapter I have taken one question which is written on this board. This question was asked in the JEE examination, that is in the IIT-JEE examination in, I think, 2016. So now this question is based on from the topic of errors in measurement. So here the question here is, a student measures the time period of 100 oscillations of a simple pendulum 4 times. The data set is given here, that is the time period measured by that student is 90 seconds, 91 seconds, 92 seconds and 95 seconds. If the minimum division in the measuring clock is 1 second, then the reported mean time is, so there are 4 options here. So now I have already created one playlist by the name of units and measurements. So in that playlist I have discussed in detail about the topic of errors in measurement, in which I have discussed about the absolute error, the mean absolute error, what is the percentage error, what is the this relative error. So you can access that playlist and you can go through that topic in detail. So now here we have to find the reported mean time. This is what we have to find. So as we all know that the absolute error is equal to, there are two formulas for this absolute error. One is, that is equal to true value minus observed value, and second is the mean value minus observed value. Now this formula is used when the true value is known to us. But when the true value is not known to us, then we have to calculate the mean value. So in this case, since the true value is not known to us, we will be calculating the mean value. So what is the mean value here? The mean value will be equal to 90 plus 91 plus 92 plus 95. 90 plus 91 plus 92 plus 95, and it will be divided by 4. So this is equal to, this is equal to 90 plus 91 plus 92 plus 95 divided by 4. This is equal to 92 seconds. Now, the absolute error, because in this question, first of all, we have to calculate the absolute error. So the absolute error for each and every measurement is to be calculated. So absolute error is to be calculated for each and every measurement. So for the first measurement, let us say the absolute error will be equal to, let us say the absolute error for the first measurement is, I am taking as delta A1. This will be equal to the mean value, which is equal to 92 minus observed value. What is the observed value? This is 90. So this is equal to 2 seconds. The absolute error of the second measurement, which I have taken it as delta A2, which is, this will be equal to 92. This is the mean value minus 91. So this is equal to 1 second. Then the absolute error for the third measurement, this will be equal to 92 is the mean value minus 92 is the observed value. So this is equal to 0 second. And the last one, that is the absolute error for this last measurement, will be equal to this mean value minus observed value. So mean value is equal to 92 minus 95. Now here, whenever we are calculating the absolute errors, we mean that it is the maximum value of error, and here basically error is the deviation from the true value. So here the deviation is 3 seconds. So we don't have to consider the negative sign. We will be simply taking the deviation, that is, which is equal to 3 seconds. So the total absolute, so we have now calculated the absolute error of each and every measurement. This is equal to 2 seconds, 1 second, 0 second and 3 seconds. Now, the next step is the calculation of the mean absolute error. So the calculation of the mean absolute means we have already calculated the absolute errors, so we have to calculate the mean of it. So this is equal to 2 plus 1 plus 0 plus 3 and divided by 4. So this is equal to 2 plus 1, 3 and 3, 6 divided by 4, which is equal to 3 by 2, and we can see this is equal to 1.5 seconds. So the mean absolute error is equal to 1.5 seconds. Now, now here if the minimum deviation in the measuring clock is 1 second. Okay, since the minimum deviation in the measuring clock is 1 second, therefore the reported mean time will be equal to the mean value, which was equal to 92 second plus minus. Now here the mean absolute error is 1.5 second and the minimum deviation in the measuring clock is 1 second. So therefore the reported mean time will be what? This will be equal to 92 plus minus 2 seconds. Because this measuring clock can measure 1 second and after that it will measure 2 seconds. So in that case, since our mean absolute error is 1.5 second, therefore the mean reported time will be 92 plus minus 2 seconds. So in this case, so our answer will be the correct option will be A. That is 92 plus minus 2 seconds. So in this question, the most important thing is that because the true value was not given, we have to calculate the mean value of the measured data. After that, we have to calculate this absolute errors as we have calculated here, and thereafter we have to calculate the mean absolute error, and after that this reported mean time can be calculated. So thank you very much for joining this session. That is the session number 1 of JEE Physics Part 1. So in the next session, I will be continuing with the same chapter, that is the units and measurement, and I will be coming up with the questions which were asked in the JEE examination. Apart from that, I have also I also have another this JEE Physics playlist, that is the JEE Physics Part 2 playlist. And in that playlist, I have taken up the questions starting from the chapter of electric charges and field. So thank you very much again, and till then, Till the next session, have a nice day. Bye.